Problem 4. M and N do not equal 0. 2007 to the nth power plus 2008 to the nth power is divisible by 7. So we can, if we go like this, and you draw a line, and there's 7 on the other side, it means that this whole thing is divisible by 7. What is the least possible value of m plus n? Because it says least possible value, we know that there's multiple values. And we don't really know. And we know, it's big numbers, 2007 and 2008. It's just that we don't know what is the value of their exponent. So it doesn't, at first it might not seem it's possible or useful if we're going to use a table, but still we're going to find the pattern. So let's first do 2007 to the nth power divided by 7. And so 2007 divided by 7, that's let's first do 2007 divided by 7. That's equal to, first that would be 260 with a remainder of 5. So the first one would be 5. Now let's do 2007 to the second power divided by 7. Well, that remainder, right? We talked about this, I believe in the second problem. And if we know that the first one has a remainder of 5, remember 2007 is equal to the second power is equal to 2007 times 2007. And remember, the remainder of the product is equal to the product of the remainders. So if we know that the remainder that we're going to get after 2007 is divided by 7 is 5, and this is also 5, we just multiply those two things together and we get 25. But it doesn't make sense to write 25 as a remainder of 7 because 25 is greatly greater than 7. So we can get 4 because 25 minus 21 is equal to 4. Now we just multiply 5 to every last remainder that we get until we get that repetition. So 20, and that would be 6, 30, and that would be 2, 3, and 3 times 5. Wait, okay. So yes, 3 times 5, that's 15, and that would be 1. And reaching 1, we know that that's the end of our rotation because it's just going to be repeating all over again, and then it'll be 5, 4, 6, 2, 3, 1 again. So if we know that this is the rotation of 2007 to the nth power divided by 7, let's do 2008 to the nth power. 2008 to the nth power divided by 7, and let's see, 2008 divided by 7 is equal to, well, 2002 actually, is a multiple of 7. And 2008 minus 2002 is just 6. So that first one will be 6. Now you do that again and you'll get 1. And if you keep doing this, just the same procedures we used in using 2007 divided by 7, you'll realize it's just 6161 rotating onwards. Okay, and let's go back to the problem for a sec. What is the least possible value of n plus n? And also n is the exponent of 2007, n is the exponent of 2008. So since we also know that this is divisible by 7, then we need these two, 2007 to the nth power plus 2008 to the nth power, added, that sum has to be divisible by 7, meaning that the remainders added together when divided by 7 has to equal 0. So let's start with 2008 over here. We only have two values, 616161. So we can only use either 6 over here or 1 over here. And this, since this it's just repeating, that's irrelevant. So we have 6 1 over here and 6 1 over here. First, if we choose this 6 on the second line, then we're going to have to choose the 1 on the first line. And as you can see, this one is very far back. This is 1, 2, 3, 4, 5, 6. This is when m is equal to 6. This is when n is equal to 1. If we choose the one on the second row, however, then this is when n is equal to 2, so the n increased, but the m decreased by 3. This is what the 6 on the top row is when m equals 3. 6 plus 1 equals 7. But 3 plus 2 equals 5. So 5 is the least possible value of m